I am Richard Feynman, and when people hear the word spacetime, they usually imagine a complicated scientific term invented to confuse them. Something abstract, something mathematical, something far removed from everyday life. That belief is dangerously wrong. Spacetime is not a theory layered on top of reality. Spacetime is reality. Everything you have ever experienced, motion, rest, cause, effect, before, after, exists only because space-time has the structure that it does. Space and time are not two separate things stitched together by physicists. They were never separate to begin with. Treating them as independent is a human habit, not a feature of the universe. We separate them because our lives move slowly, our speeds are small, and gravity feels weak. Under those conditions, space-time disguises itself. But once you look carefully, once you push nature even a little, the disguise fails. Space bends, time stretches, simultaneity collapses. And what you're left with is a single four-dimensional structure where every event that ever happens already has a place. The mistake most people make is thinking space-time is a stage where the universe performs its play, as if objects move through space while time ticks in the background. That picture feels natural, but it is completely false. There is no background clock. There is no empty grid waiting for things to happen. Space and time are part of the same fabric, and that fabric reacts to energy and motion. When something moves, space-time rearranges itself. When energy concentrates, space-time curves. Objects do not move in space-time the way actors move across a stage. Objects trace paths that define space-time relationships. Motion is not happening against space-time. Motion is how space-time is revealed. Once you understand this, you realize why physics stops making intuitive sense. Your intuition evolved to survive at walking speeds on a small planet, not to understand a universe where geometry itself is dynamic. Space-time is not a thing you can point to. You can't touch it. You can't isolate it in a jar. And yet, it controls everything. The distance between two events is not just a matter of meters. It is a combination of space and time together. Two observers moving differently will measure different distances and different times between the same events, and both will be right. That is not a paradox. That is space-time doing exactly what it must do to remain consistent. The universe does not care about your common sense. It cares about preserving the geometry that keeps cause and effect intact. Once you accept that space-time is the real structure of the universe, strange things stop being strange. Time slowing down, lengths shrinking, light setting the ultimate speed limit. These are not odd behaviors layered on top of reality. They are direct consequences of how space-time is built. One of the hardest ideas for people to accept is that there is no such thing as absolute space. In the old Newtonian picture, space existed on its own, perfectly rigid and perfectly still, whether or not anything was inside it. Time marched forward independently, the same everywhere. That picture worked well enough for everyday life, but it was never how the universe actually behaved. Space-time replaces that entire framework. There is no preferred state of rest. There is no fixed grid that defines where things truly are. Every measurement of space depends on how you are moving. Every measurement of time depends on how you are moving. Space-time does not give you positions and moments. It gives you relationships between events. Once you understand this, you stop asking where something really is, or when something really happens. Those questions assume an absolute background that does not exist. What exists instead are events and the space-time intervals between them. Physics concerns itself only with those intervals, because those are the things all observers can ultimately agree on. Motion in space-time is not simply changing position. Motion is a redistribution between space and time. Every object moves through space-time at a constant rate, but that motion is divided differently depending on speed. When you are standing still relative to me, all of your motion is through time. When you start moving through space, some of that motion is redirected away from time. That is why moving clocks run slow. It is not because something happens to the clock. It is because the clock is tracing a different path through space-time. This is geometry, not mechanics. The universe is not slowing clocks down. It is assigning them different space-time paths. Once you see motion this way, time dilation is no longer mysterious. It becomes inevitable. Any universe with space-time structured the way ours must behave this way. This also explains why the idea of a universal no collapses the moment you take space-time seriously. In space-time, there is no unique way to slice the universe into moments of time. Different observers slice it differently, and none of those slices is privilege. What you call no is just a particular way your motion through space-time organizes events. Someone moving differently organizes them differently. Neither description is more real than the other. The universe does not come labeled with timestamps. It comes with events connected by space-time geometry. When people insist on a single present moment, they are importing a human convenience into a universe that does not require it. Space-time does not care about your sense of simultaneity. It only cares about preserving the causal structure that keeps physics consistent. To really understand space-time, you must understand why the speed of light is not just another speed. It is not fast because light is special. Light is special because space-time has a built-in structure that allows no faster motion of cause and effect. The speed of light is the conversion factor between space and time. It tells you how much space equals how much time. Change that number, and you change the universe itself. Once you see this, you realize why nothing with mass can reach that speed. As an object accelerates, space-time forces more of its motion into the spatial directions, leaving less for time. At the limit, time disappears entirely. This is not an engineering problem. It is not about fuel or materials. It is geometry enforcing consistency. Space-time will not allow contradictions. Light sits exactly on the boundary of space-time's structure. It defines what events can influence what other events. This boundary, the light cone, is what protects causality. Everything that can happen to you lies inside your past light cone. Everything you can influence lies inside your future light cone. Events outside those cones are forever disconnected from you. This structure exists whether or not anyone observes it. Space-time is not a stage waiting for actors. It is a network of causal relationships, and light draws the boundaries. Without light speed as a limit, cause and effect would unravel. The universe would be inconsistent. That single fact, that information cannot travel faster than light, is what allows reality to make sense at all. This also explains why space-time feels rigid and flexible at the same time. Locally, space-time looks flat. You can walk, throw objects, live your life without noticing anything strange. But globally, space-time curves, stretches, and warps under energy and momentum. That curvature is not happening in space. It is space. Gravity is not a force pulling objects along invisible strings. Gravity is space-time geometry telling matter how to move. And matter, in turn, tells space-time how to curve. This mutual relationship is not poetic language. It is the literal content of Einstein's equations. Space-time is active, it responds. It participates. And once you see that, you stop thinking of the universe as a collection of objects and start seeing it as a dynamic structure. Most people think of gravity as a force, something that pulls objects downward. That picture is useful for simple calculations, but it hides the truth. Gravity is not a force in the usual sense. Nothing is being pulled. Nothing is being dragged. What we call gravity is simply the natural motion of objects through curved space-time. When space-time is flat, objects move in straight lines. When space-time is curved, those straight lines look bent to us. An object in free fall is not being forced. It is following the straightest possible path space-time allows. That's why astronauts feel weightless in orbit. They are not escaping gravity. They are completely immersed in it. They are falling freely through curved space-time, just like the Earth is falling around the sun. Weight, then, is not gravity acting on you. Weight is the resistance you feel when something prevents you from following your natural space-time path. Once you understand gravity this way, time immediately becomes involved. Space-time curvature does not affect space alone. It affects time even more strongly. Clocks closer to massive objects run slower than clocks farther away. This is not a mechanical effect. The clock is not damaged or disturbed. Time itself is stretched by curvature. The deeper you go into a gravitational field, the more space-time tilts towards space and away from time. A clock on the surface of Earth ticks more slowly than one in orbit. A clock near a black hole ticks unimaginably slowly compared to one far away. These effects are not theoretical curiosities. They are measured every day. GPS satellites must correct for gravitational time dilation, or your navigation system would fail within minutes. Space-time is not an abstraction. It directly controls the technology you depend on. What makes this even more unsettling is that no clock is wrong. Each clock measures time correctly along its own path through space-time. There is no master clock with which all others must agree. Time is local. It belongs to the path, not the universe as a whole. When people ask which clock shows the real time, the only honest answer is, all of them do. The universe does not synchronize itself for your convenience. It allows each system to keep its own time, dictated by motion and gravity. This is why space-time is such a radical departure from classical thinking. It replaces absolutes with relationships. It tells us that reality is not built from fixed backgrounds, but from interactions between energy, motion, and geometry. To see space-time without its disguises, you have to look at the most extreme objects the universe creates, black holes. Near a black hole, space-time is not gently curved. It is violently distorted. Space is stretched. Time is slowed to a crawl. From far away, an object falling toward a black hole appears to freeze at the edge, never quite crossing it. This is not because the object actually stops. It is because time near the black hole slows relative to distant observers. The closer you get, the slower your clock appears to tick. Space-time itself is tilting so steeply that what you think of as time begins to behave like space. The equations do not break here. Your intuition does. Black holes are not strange because physics fails. They are strange because physics finally shows itself honestly, without approximation. The boundary of a black hole, the event horizon, is not a physical surface. It is a space-time boundary. It marks the point where all possible future paths lead inward. Once you cross it, the structure of space-time changes so completely that moving forward in time means moving toward the center. You cannot avoid it any more than you can avoid tomorrow. Inside the horizon, time and space effectively swap roles. This is not poetic language. It is mathematical fact. What this teaches us is something profound. Time is not guaranteed to behave the way you expect. Its behavior depends entirely on space-time geometry. Change the geometry enough, and time becomes something unrecognizable. The universe does not promise continuity of experience. It promises only consistency with its equations. This is why black holes terrify people, not because they are deadly, but because they expose how fragile our everyday concepts really are. Past, present, and future are not sacred categories. They are conveniences that work in weak gravitational fields at low speeds, near extreme space-time curvature. Those categories dissolve. Events that seem separated by time from one perspective can become spatially separated from another. What you call frozen time at a black hole is just space-time geometry, doing what it must to preserve causality. Nothing mystical is happening. No laws are being violated. The universe is simply reminding you that space-time is the fundamental structure, and your experience of time is a local, limited interpretation of it. When you push space-time down to the smallest scales imaginable, something extraordinary happens. It begins to lose its meaning. At the quantum scale, the smooth geometry we rely on simply refuses to cooperate. Distances fluctuate. Energy pops in and out of existence. The idea of a sharply defined space-time point becomes impossible. Quantum mechanics does not describe particles as moving along neat paths through space-time. Instead, it describes probabilities, clouds of possibility. And here we encounter a deep problem. Quantum mechanics treats time very differently from space. Space is something we can measure and quantize. Time remains a parameter, a background label. This mismatch tells us that space-time, as we currently understand it, cannot be fundamental. It works beautifully at large scales, but at very small scales it becomes an approximation. Useful, accurate, but incomplete. This is where people often ask whether time itself might emerge from something deeper. And that is a reasonable question. If space-time breaks down at the quantum level, then time cannot be the ultimate ingredient of reality. It must arise from more basic relationships. Some approaches suggest that time emerges from quantum entanglement. Others suggest it comes from information flow. What they all agree on is this: time is not a primitive concept. It is not written into the universe at the deepest level. Instead, it appears when systems become complex enough to define stable sequences of events. In other words, time is not something the universe has. It is something the universe does under the right conditions. This realization forces us to rethink what we mean by reality itself. If space-time is emergent, then the universe is not evolving moment by moment the way we imagine. All events may exist within a larger structure, with time acting as a way for limited observers, like us, to navigate that structure. Physics does not say the universe is frozen or static. It says the universe is relational. Change exists, but flow is not fundamental. Motion exists, but a universal clock does not. Space-time gives us a remarkably accurate description of how events relate, but it may not be the final word. The deeper truth may be written in a language we are only beginning to learn. So when people ask me what space-time really is, I tell them this space-time is not a container holding the universe. It is the universe's rule book. It determines what can happen, what cannot, and how events relate to one another. It tells particles how to move and tells energy how to shape reality. There is no separate stage behind the scenes. There is no ticking clock driving the universe forward. What exists are events connected by space-time geometry, obeying a structure that does not care about your intuition or comfort. Space-time does not flow. It does not age. It does not wait. It simply is. And everything you experience, motion, gravity, cause, effect, past, and future, emerges from how your world line cuts through that structure. Once you see this, you stop thinking of space-time as an abstract idea and start recognizing it as the deepest description of reality physics has ever produced. The real truth about space-time is not that it is strange or mysterious. The truth is that it works relentlessly and without exception. It explains why time slows, why space bends, why light sets the ultimate speed, and why no observer gets a privileged view of reality. It tells us that the universe is not built from objects moving in time, but from relationships between events. Humans experience time because we are complex, slow, thermodynamic systems that record information and increase entropy. The universe itself does not experience anything. It obeys structure. And that structure is space-time. Once you understand this, you don't feel smaller. You feel connected. You realize that your life, your motion, your memories are all threads woven into the same fabric that shapes stars, galaxies, and black holes. That is not a loss of meaning. That is meaning grounded in reality. And that is the truth about space-time.